is Thursday, May 22nd, 2008. We are in Rome, in the building of the Italian Parliament, and I'm interviewing the Garwin. We will give today a lecture on the prospect of the energy future. I think maybe in this interview we could focus on the, so to say, positive aspects of what should be done in the short run and in the medium run, so decades and centuries. And the two problems are shortages of energy that one is worried about, and impact on the environment, particularly CO2. What do you think are the most important things to be done in the immediate and medium future to address these problems?
Well, fundamentally, one needs to have alternatives to petroleum. It's not that we're running out of energy, we're running out of cheap energy, we're running out of environment, and we're running out of the national and international will to solve these problems, to quote a good friend of both of ours, John Holdren. So on the nuclear side, we have 103 nuclear power plants in the United States and more than 400 in the world, producing about 17% of the electrical power of the world. I think that that can be expanded substantially, but nuclear plants are costly, they take a long time to build, and there's no prospect for a really great expansion to the level that I think is warranted. I think we could build thousands, 9,000 nuclear plants instead of the current 400, but it would require an enormous creation of an industry and creation of an industry to support that industry in order to do that. There is enough uranium in principle, although we need to do more exploration to determine the supply curve, that is the cost of uranium as a function of millions of tons that have been produced. Every reactor takes about 200 tons of raw uranium a year, so 10,000 reactors would take 2 million tons of uranium, not very much. A coal-fired power plant takes 2 million tons of coal for a single power plant. And we need to handle the spent fuel, which has been a lot of controversy, but should be solved by competitive commercial mined geologic repositories. And those should be monitored and authorized by the International Atomic Energy Authority. And ultimately, when breeder reactors that use 100 times less uranium are cheaper than light water reactors of the present type and safer, then we might move to those breeder reactors, or if the cost of uranium, the true cost of production, increases, to make them feasible. Of course, we don't want to make nuclear weapons with all of those reactors, and so we have to continue and strengthen the Non-Proliferation Treaty and the international will to prevent the manufacture of nuclear weapons by countries that deny any desire to have nuclear weapons. So nuclear sector should advance. It has problems of cost. Ultimately, there are problems of terrorism, because an accident in a nuclear power plant that breaches the containment dome is very serious, and one has to take it seriously and prevent it. But much of the use of petroleum is for transport, and it's hard to replace there. Liquid fuels, diesel fuel, gasoline store an enormous amount of energy compared with batteries. So while I favor hybrid cars and plug-in hybrid cars, that's not going to solve a lot of the problem. It will solve some of the problem. The rest we can handle by making liquids from biomass, from crops, initially from waste crops, not the fruit of corn plants, but the structure, the cellulose, converted into liquids for transportation. And we can do it by making liquid fuel from coal, but that comes up against the other problem that you mentioned, the increasing amount of carbon dioxide in the atmosphere. We have 380 parts per million. Before the Industrial Revolution, there were 270. And the problem is that carbon dioxide is a greenhouse gas. That is, it absorbs and reflects infrared and blankets the Earth, keeps it warmer than it would otherwise be. Of course, the greenhouse effect is essential. The greenhouse effect of water is what makes the Earth a place where life can exist. Otherwise, it would be totally frozen. So a modest amount of greenhouse effect, which is what we have, which is what we've grown up, plants, animals, in millions of years to adapt to, is just right for us. And 450 parts per million, 550 parts per million, that will be reached in the year 2030. To exceed that would bring, in my opinion, catastrophe, and maybe even unknown catastrophes besides the warming and the increased incidence of storms.
In the guise of warming up and also maybe the whole turbulence of the atmosphere, I mean, these are the type of catastrophes that would be brought about
Yes.
by the increase of the greenhouse effect of warming.
Well, the problem is that the weather, the climate, where people are and where crops are grown would become unsuitable for them. And the climate elsewhere would become more suitable for agriculture, but that would involve enormous transfer of resources and people to these new areas with all kinds of potential for conflict. Whole countries would be rendered unsuitable for agriculture as we know it. So whereas we see the polar bears are in trouble, the glaciers are melting, and many other visible effects of global warming, these would be really serious for people, not just for the polar bears, not for tourism to the glaciers or skiing. And so
what to do?
So the energy problem is a terribly difficult one with long-lived systems, automobiles 10 years, power plants 60 years, buildings 40 or 100 years. The carbon dioxide problem is a very serious one. The combination of the two is almost insuperable. So what to do? Physically, one can use carbon capture and storage, previously called carbon sequestration, so that power plants, which in the United States mostly use coal for generating electricity, and spew the carbon dioxide into the atmosphere. Each plant takes 2 or 3 million tons of coal per year and produces 3.7 times that much, 10 million tons of carbon dioxide. Those 10 million tons can be captured and piped for disposal either in underground aquifers or in the deep ocean, where the carbon dioxide would exist as liquid in deep pools, or perhaps injected into the seabed. So the time has finally come for, at scale, that is multi